Me and Andrea are going to present you our algorithms and data structures project. So, when it comes to writing essays, writing emails, or every task that generally involves writing, we tend to commit some mistakes. For example, writing a word or deleting a paragraph that we thought that we don't need it, but we end up needing it. So for this problematic, we ended up thinking about the undo and redo functions. And the undo users step back and delete temporarily a part of the text that you don't need anymore. And on redo, if you tend to need it in the future, you can add it again. So this is mainly the problem that we are analyzing. We search and analyze for different data structures that could be the best fit for this issue. We thought about vectors, linked lists, and stacks, but we ended up deciding on stacks because of the following advantages. The stacks provide us simplicity and efficiency. Overall, the complexity time of stacks is 0.1. Because of the push and pop operations, they both involve only 0.1 complexity, regardless of the number of elements that are in the stack. Also, it has an ease of tracking state. Stacks work with something called LIFO, which stands for last in, first out, which is really very useful for undo and redo because the last thing that you add to the stack is the first thing to go. It is intuitive for undo and redo. Also, it has an automatic memory management. This was very important because we don't have to handle pointers and more memory elements added to our memory block, because when we pop an item from the stack, it is automatically removed from the memory.
Yeah, well, we select basically the stacks because of its nature. It is mostly used for undo and redo functions because of the pop and push. How can I say it? Well, yeah, kind of functions like that. Yeah. Well, if we want to redo, we have to add the text we had previously undone. That's why we push when we want to redo. And when we want to undo, we can easily pop the last thing we add. As the stack works with the LAFO, last in, first out theorem. And well, explaining that, it works like a pile of plates. If you add one at the top, you can easily remove that from the top, as we want to do in the redo and undo function with a time complexity of 1. In comparison to the linked list that you need to go through all the list, or in the vector that is not that easy just to remove the last element. Well, this helps us out. And it also like keeps the order of the actions made in the past. You don't have to have this problem of which one was first and which one was the last one. It's easier to manage. Now we're going to explore a little bit in our code in an easy and visualized way. First of all, we made this meme that is simulating the editor's moves in the text. First of all, we create, well, the functions we are going to, and methods, we're going to explore it a little bit later. Not at all, but a little. First, we call the editing function, which mostly adds text. We call bread and jam. Yeah, and now we print what sandwich has, that is bread and jam, literally those words. Then we call the undo, well, it will make only delete the jam word. because was the last added. After that, we call the redo, which will make the jam word appear again, or redo the function. And now we can have the first text that would be the output of bread and jam. That was the first, but undone and redo. Yeah. Now we're gonna go a little bit to the editing function. First of all, we initialize the stats and the variables that, well, the variable is pref text and the stats are undo and redo. Well, first of all, we save the pref text in the undo push. If we want to undo, we will need it saved. It's just for if it's needed. If it is not, it will stay there because nothing happens. Well, you add the new text to pref text. Well, as we did before, we had bread and then we added and then we added jam. Well, they make just pref text added to the pref text. And well, then we check if redo is not empty, then we're gonna pop it because we need it empty for future work. Yeah. Then we have the main characters of this code. We have the undo function, which is a stack, and the redo function, which is another stack, working to undo and redo the text. First of all, we have to check if undo is not empty. Well, if it's not if it's not empty, we save it in the redo stack. If it's if it's not empty, we save it. If we want to redo later time, we set the pref text to undo top, and finally we pop undo top because we don't want a long stack. You can, it's like more efficient. We don't need that long stack. Yeah. And then we have the redo function, which basically checks if redo is not empty. And if it's not empty, we save the text, the previous text to in undo for later use. And then we set pref text to redo top, and then we pop redo at the same for avoiding a long stack. Mainly the function of redo and undo are in these stages. They're basically moving to one to another using the pref text that is they work like really hand by hand because for doing this works with this, and for that we work with that. They're crisscross, but yeah, that's mainly how they work.
For us, it was very important to find a data structure that was efficient and had a good memory management. And as we can see, the stacks have a natural behavior with undo and redoing. It's basically what they do with the push and the pop is just what we needed. So that's what we decided for this data structure. And here is the code on it. And as you can see, it's just what Andrea explained. Sandwich has bread, now I have bread and jam, now I have bread and bread and jam. So that's basically what the undo and redo functions do.
Yeah. Yeah. Also, first of all, before analyzing everything, we were thinking about this other. Well, the things we were seeing in class, like linked list, firstly, then after a long research, we found the pop and the push, and it was incredible. Well, that's it. First of all, like we tried with the integers, and that's very easier to work with than the strings, but then we could apply it there. Well, that's it. Downwards is the main, because first we created the methods, then we created the main,
Thank you.